So it seems to be a good idea. So I don't want to go into any math details, but there's one thing that I think can be understood looking at the picture. So I'd like to explain to all the people in the room what we do. From this point of view, I think it could be sort of understood. So the idea, we have to solve an optimization problem. We have to find the minimum of the function. And it's like when you have a, well, we want to find a value for which there will be a minimum of some sort in a graph, in a plot. But this plot lives in a very high dimensional space. And one thing we want to do is to want to select a small number of the variables that will allow you to solve the problem. And the way you can think about the way you go about is the following. It's like you want to minimize a function and you add some penalty terms to your minimization, because the way it goes is the following. There could be a very simple way to minimize the thing is to use all the expressions we are given. And maybe using all the expressions we are given, we can find a perfect fit such that this value here is 0. So using sparsity as a driving force is like saying, well, but wait, if you use all the expression, whenever you use one expression, you have to pay a price. And the price you pay is the fact that is how much of this expression you're going to use to describe your function. And the more expression you want to use, the higher the price you have to pay. So the way you pay a price, you can think about the way you pay a price with this drawing. If you square well, let me just one step back. Simply counting the expression, which is the most natural thing to do, would lead us nowhere, because the way counting expression is too expensive. It's so expensive, we don't have enough time, we don't have enough computers, we don't have enough, I don't know, the time, the universe. I mean, there's no way of solving such a problem simply counting the expression. Is what is called an MP problem in the computer science jargon. It's just too difficult, right? So there's no way, it's intractable. So mathematicians and computer scientists came up with proxy. So instead of counting, well, you just measure how much of this expression you want to use, how large is the coefficient, and then you could square it, or if you take the absolute value. Now, the interesting bit is that if you go with the sparsity, it's like saying that you want to find a way in which, well, you can convert that problem as the following. You have a line, and you want this line to hit either a circle or a square, a diamond in this case. Now, the interesting bit is that when with the line, you hit the circle, no matter how the slope of the line will hit the circle in a point which will have a little bit of x1 and a little bit of x2. While if you want to go to a minimization in which you have to hit a diamond, since the diamond got vertices, you will hit, well, unless you're very lucky or unlucky and being parallel to one of the sides, you will either hit here or here or here or whatever it is, but only one point. So there will be one component different from 0, x2 in this case, and x1 will be 0. So effectively adding this term here buys you what is called a sparser solution. And that's what is behind what we do. I don't want to get into whatever, I mean, all the technicalities, but we're quite fond of what we developed over the years. We have also a theorem saying that this is actually leading us to the true solution. In the unlikely event, we're going to see zillions of examples, but that's reassuring. I mean, would we be able to collect all the possible gene expression in the world, or actually more than that, and then our solution would go through all the optimal. Of course, we have only 40, so right, we have to live with this fact. But anyway, so for this reason, we have to play with the parameters, but we set up a careful, bias-free framework in which we can actually select the model and do all the things in a way that we are sort of reassured that despite the fact we're working with a formidable problem, we can provide some significant statistical significance to the list we suggest to the clinicians and to the biologists.